Good afternoon, Professor. Today, I'm going to present the evidence problem situation with the use of cutting-edge technology. My name is Jose Manuel Garcia, and I'm going to start. Well, today we are going to talk about Netflix. This company is dedicated to the service of series, movies, and documents in his own platform of streaming. Today, we're going to see his earnings, his revenue from the date 2005 to the date 2036. We're going to predict the revenue of this company with different functions. Well, as we can see here, we have the Netflix incomes. I make this table in Excel. As we can see here, we have the graphic of the revenue, $1 billion versus the years to the year 2005 to the years 2020. Okay, we're going to the first question. It is possible to use linear functions to represent the yearly growth. Find a function to represent this yearly growth. The answer to this question is yes, it is possible. And the function for this using the trend line of this graphic is this. J equals to 1.3942x minus 4.7869 is this one. And his coefficient is 0.7985. It is necessary to know that this function that follows the trend line has a margin of error of 29%. And this is because the coefficient is 7.79. If the coefficient is nearest the 1, is better because we have lesser margin of error. We have another graphic of this function, but this one on GeoGebra. Okay, we're going to see the functions of the change of every year in year 2005 and 2006 is a change and the same in all the years consequences. We have the function of growth of the year 2005, 2006, 2006, 2007, and all of them. We have them here to know her growth. And that follows us to the second question. Make a fit using a different kind of function. Justify your decision. Is the proposed function more accurate? Is there any statistical coefficient that can be used to determine the precision of the predictions? Explain it. Well, after I investigate on internet and on Excel, I moved some tools on Excel. I found that we have another function, an exponential function for this chart of incomes. And this is it. As we can see here, this is the exponential function that is equal to J is equal to 0.5548 exponential 0.23 and 52x. And yes, these equations, like the first one, also have a statistical coefficient that helps us to know the margin of error. And the good thing about this coefficient is that it's a 0.9972. What does this mean? This means that us only have a margin of error of 1%. Look, if we go here to the Excel, we can see that here in the graphic, we can follow the trend line. We can have a logarithmic. If we got a logarithmic and we present the equation, we'll have a lesser coefficient. As you can see here, we have a 0.5 with a lineal. The first one is a 0.7 with an potential. We have a 0.85, but the nearest function that leads us to only the 1% of margin of error, it's an exponential function. and it is the one that we are using. As you can see, we only have a 1% margin of error. Okay, I use this one because this is the one that have a less percent of margin of error. We are going to go with the third question. With the function from point 2, predict the revenue expectations for year 2035. Write an analysis on the findings. We know that the year 2035 is a future year. We don't know really what is the earnings of this company right now. Will we have a function to predict this? In the projection of the year 2035, this is the function that we will have. It's y equals 0.55 and 48 exponential 0.23 and 52x. These potentials of GD1. And the answers to this function is an income of $814 billion in the year 2035. This is following continuous growth, which it's frankly a ridiculous amount and an unrealistic from a company of this style. As I have mentioned many times in this analysis, this is only merely theoretical, using functions and statistics and not counting social and political factors. We are going to the 4 questions. Is there a limit to growth? What does depend on? Elaborate. The answer for this is a simple no. As you can see, is no limit to growth with this function. We can make predictions with this type of function applying to every company in the world, every company that have revenues and have 2 factors, obviously. But we don't have to, but we don't know if there's going to be this company is going to be a collapse, if there's going to be another pandemic like the pandemic we're living. We don't know that factors, and that's because we are not taking this as a real prediction. This is only a simulation if Netflix continues with its annual growth. That's the question, and we're going to the question number 5. Propose a method to complement the function proposing the points 3 and 4. While it's not necessary to find a mathematical function, you have to explain your proposal using either mathematical concepts or reference. Okay, I did some research and I was able to come up with this formula to record the Netflix growth, and this is one. We have to, as we see in this table, we have to have 2 factors, the time and the income, to the actual income and the last income. We have to get the current time span income, and to that minus the previous time span income. Then as the result of that, we have to divide them into the previous time span income. And if you want to make a percentage of growth, you have to multiply that last result by 100. For example, as we can see in this table, we have an income in December this month of $2,654. And the last span income, we have $2,368. These equals of that, the equals of December minus November, we have $286. The second part of this formula is to divide $286 into the last span income, that is in November, with $2,368, which leaves us with this result, that is 0.12 and 0.07. With that, we go to the third part of this formula, that is, and this is optional. We have to this third part that is optional, that is to multiply the result of that, that is 0.12 and 0.07 per 100. That will leave us with a 12% of income growth. That is a formula that I invest, and it is good to know the growth of the empress. We can make that with the incomes of Netflix easily. And that's all the work. Thank you, teacher, for giving the opportunity of take this presentation alone. My teamwork doesn't answer me the question. That's bad, but I am here. And this is the bibliography. I put the same bibliography that you use in the situation problem that you put us in Canvas, and that's all. We can see here the graphs that I use, the graphs with the line function and the exponential function and the table of incomes of Netflix. Thank you for listening. Have a good afternoon in you, and that's all. Thanks.